What are level-triggered interrupts in microcontrollers? Imagine you're trying to keep a light on until someone turns it off. In microcontrollers, this idea is similar to how level-triggered interrupts work. These interrupts are signals that stay active as long as a certain condition exists. When a device or sensor holds a line at a high or low voltage level, the microcontroller recognizes this as an interrupt request. The key point is that the signal remains at that level until the system clears it. In simple terms, if a sensor detects a fault and pulls a line low, the microcontroller will keep noticing that low signal as long as it stays low. It will keep asking for attention until the firmware clears the condition. This is different from edge-triggered interrupts, which only respond when the signal changes from high to low or vice versa. Level-triggered interrupts are more about the current state rather than the transition. This type of interrupt is useful when the condition that causes the interrupt is ongoing. For example, if a button is pressed and held down, the line stays active. The microcontroller can keep servicing this request until the button is released and the line is cleared. But this also means the firmware must be careful. If it doesn't clear the interrupt properly, the system might keep servicing the same request repeatedly, causing what is called interrupt flooding. Electrical engineers like level-triggered interrupts because they are simple to detect. The signal is stable during the request, making it easier for the microcontroller to recognize. However, because the interrupt keeps reasserting as long as the condition exists, it can increase the load on the processor. To prevent this, firmware needs to acknowledge and clear the interrupt once it has handled the condition. Many microcontrollers allow configuring external pins for level-triggered interrupts. The system might requiring the signal to stay at the active level for a certain minimum time, often a few machine cycles, to qualify as a valid interrupt. This helps avoid false triggers from noise or brief glitches. In embedded systems, understanding whether an interrupt is level-triggered or edge-triggered helps in designing reliable and efficient programs. Level-triggered interrupts are especially handy when the condition needs to be addressed until it is resolved. They are a simple way to monitor ongoing signals, but they demand careful handling in the firmware to avoid unnecessary repeated servicing. So, in summary, level-triggered interrupts are signals that stay active as long as a specific condition exists, prompting the microcontroller to respond repeatedly until the condition is cleared. They are a vital part of handling ongoing or sustained events in electronics and embedded systems.